Alternative theory of gravity. In this video I'm going to present an alternative theory of gravity. I'll start the presentation with an explanation of the nature of gravity. I'll compare the interpretation of gravity given by my new theory with Einstein's general theory of relativity. Then I'll talk about the energy of mass, and present the new meaning of Einstein's famous formula, E=mc². In the third part I will derive Newton's law of universal gravitation. Then I will talk about time and the time dilation formula. The last part will discuss the implications of my theory, about the repulsion of masses, the critical density of mass and other topics. The nature of gravity. The theory of gravity can be called a theory only if it explains the nature of gravity. And looking into the history of science we see that there were few reasonable explanations of the phenomenon of the attraction of masses. The first scientist who should be mentioned in relation to gravity is Galileo Galilei. He studied speed, velocity, gravity, free fall, the principle of relativity, inertia, and projectile motion, all possible aspects of mass and gravity. He didn't develop a theory but provided a basis on which theories could be created. Newton. Newton gave us a law of universal gravitation. Again, he didn't develop a complete theory of gravity but had very interesting ideas about the ether as one cause of gravity which I will discuss later in this presentation. Fatio and Lesage proposed similar kinetic theories of gravity with a mechanical explanation of Newton's gravitational force in terms of streams of tiny unseen particles, which impact every material object from all directions. Their theories claimed that material objects partially shield each other from the unseen particles, and this shielding creates a pull between them. Although this theory was never widely accepted by scientists, it can be regarded as one of the few physical explanations of the nature of gravity. General theory of relativity. Einstein's general theory of relativity can be considered to be the most successful explanation of gravity, and it is acknowledged as the most accepted theory of gravity. Einstein gave a mathematical explanation of the gravitational interactions between masses using a four-dimensional space-time continuum which is curved by mass. The general theory of relativity is most interesting from the point of view of my new theory of gravity because both theories have the same premises. Both theories are based on the principle of equivalence as formulated by Einstein in 1907, which is basically, we assume the complete physical equivalence of a gravitational field and a corresponding acceleration of the reference system. And I would like to highlight the part of this definition, complete physical equivalence, because as we'll see later this phrase will be very important in the logical development of the new theory. In the other words, the equivalence principle can be described as, an observer in a room without windows cannot distinguish between being on the surface of the Earth, and being in a spaceship in deep space accelerating at 1g. It is obvious that in the case of an accelerating spaceship all objects in its cabin will move with the same acceleration whatever their masses, and every object will experience an inertial force proportional to its mass and directed opposite to the direction of acceleration. But we also know that inertial forces are not real. There is no force which attracts a passenger of a bus when the bus stops. And there is no force of attraction at the back of a bus when the bus accelerates. In both cases the forces are fictitious. The fictitious nature of the force of gravity can be revealed in the case of free fall. All objects in a free-falling cabin are weightless, which indicates that they are moving in an inertial system. So, an accelerating motion by the force of gravity is an inertial motion. So gravity is not a real force. Einstein called this idea as his happiest thought. Gravity is not a force. And I completely concur with this statement. Gravity as we experience it on the Earth is not a real force. Up to this point the new theory completely agrees with Einstein's general theory of relativity. The difference starts in the interpretation of this basic fact. Einstein said that gravitational acceleration is an inertial motion in four-dimensional space-time continuum curved by the bigger mass. Astronauts flying around the Earth in orbit feel that they are moving in a straight line at a constant speed. In a curved space-time the surface of the Earth is a non-inertial frame of reference and moving upward with acceleration 1g. Curved space-time or the four-dimensional space-time continuum explains everything. But do we really understand what space-time is? Does it look like a space stuffed with clocks? Or like rubber trampoline curved with a massive ball? The four-dimensional space-time continuum is something unimaginable. In our three-dimensional space we cannot imagine something four-dimensional. It exists only on a paper in mathematical formulae. And now we can ask a question: is there a complete physical equivalence between gravity and inertia in Einstein's model? Several times when I've tried to explain to somebody the main principles of general relativity, starting with the principle of equivalence, I've been asked, does acceleration produce curved space-time the same way as gravity? Good question. Einstein said that inertia is the gravitational coupling between matter and space-time. But does this mean that there is complete physical equivalence between inertia and gravity? For me, there are more questions than answers. Do we have an answer for the question what is mass, besides that it is equivalent to energy by mc squared? Then what is energy? We are talking about space-time, but what is space? And what is time? 100 years have passed since general relativity was published, but the most popular topic on theoretical physics forums is, what is time? We agree with the statement that gravity is not a real force, but do we actually know what a real force is? An alternative theory of gravity has to answer to all these questions. Let's return to the equivalence principle, and especially to the part of it about complete physical equivalence. What does it mean to be completely physical equivalent? In this picture we can see a woman with her hair flying in the wind. What is the cause of this situation? Probably she is driving a sports car. Or maybe she is standing near to a big fan which is blowing air into her face. In the first case the girl is moving through still air, and in the second case she is standing still but the air is moving. The two cases are different but the result is the same: her hair is moved by air molecules. Both cases are completely equivalent. In the case of gravity or a non-inertial system we have to consider not uniform but accelerated motion. And we know that acceleration can be measured relative to an inertial object, like a fall, or we can use an accelerometer. In both cases we will measure proper acceleration. Proper acceleration is not the same as coordinate acceleration. For example, an accelerometer at rest on the surface of the Earth will measure the acceleration due to Earth's gravity. By contrast, an accelerometer in free fall will measure zero acceleration. Placed into a spaceship with a switched-off engine in deep space, an accelerometer will show nothing because the system is inertial. But at the very moment when the engine is switched on, the accelerometer will show an acceleration of the spaceship. Relative to what does the accelerometer measure acceleration? And there is Mach's principle, which says that local physical laws are determined by the large-scale structure of the universe. It suggests that acceleration is relative to the fixed background, which Einstein describes as the fixed stars. But most physicists believe Mach's principle was never developed into a quantitative physical theory that would explain a mechanism by which the stars can have such an effect. So, if it is not fixed stars, then what is the reference frame? Let's think about it. Our spaceship moves in an empty space, then maybe we can accept that this empty space serves as an inertial reference frame. Then proper acceleration is acceleration relative to surrounding space, and we can consider space as a universal inertial frame of reference. If we accept that on a non-inertial spaceship an accelerometer measures acceleration relative to the surrounding space, then what does an accelerometer measure on Earth? Can we expect that on the Earth it also measures acceleration relative to space? If yes, then space is accelerating relative to the surface of our planet. And it is not the Earth is moving upward as Einstein said, but it is space which is moving downwards. And now we can apply a test of complete equivalence between inertial force and gravity. We can see that acceleration of mass in space is completely equivalent to acceleration of space relative to mass, in the same way as the example with the woman driving the car or standing near to the fan. This approach lets us explain why every object in free fall experiences weightlessness in the same way as astronauts in an inertial spaceship. It happens because a free-falling object is moving together with space or with a constant speed relative to it. There is no acceleration relative to space in free fall. And now we come to the main point of the theory. How can mass create an accelerating flow of space towards itself? And there is only one answer to this question: matter absorbs space. And to balance matter, antimatter has to emit space. So, the first question for the new theory: what is mass? Mass is the property of matter to absorb space. Here comes the second question: what is space? Albert Einstein wrote in 1920, "We may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. But the idea of motion may not be applied to it." Is this true? Let's remember famous Michelson and Morley experiment, where they tried to measure speed of the ether wind, which has to exist if Earth is moving through the stationary ether. The experiment failed because no ether wind could be detected. And the main result of this experiment was, the stationary ether doesn't exist. Or, in other words, space or the ether is not stationary. Now is a good time to remember Newton's ideas about gravity and ether. Newton describes the ether as a medium that flows continually downward toward the Earth's surface and is partially absorbed and partially diffused. This circulation of ether is what he associated with the force of gravity to help explain the action of gravity in a non-mechanical fashion. Doesn't it look familiar? It's an almost exact description of my new theory of gravity. And now, returning to the Michelson-Morley experiment, we can ask, could they register a fluid ether which was moving perpendicular to the surface of the Earth? And the answer was no. The result of their experiment can be easily explained from the point of view of the new theory. Then the answer to the question what is space or the ether, will be, first, space is a discrete substance. It is hard to imagine that mass is absorbing something continuous. And second, space consists of massless cells, or particles of space, which can be moved and absorbed by mass. I prefer to use the term space cells instead of particles, because the notion of particles implies that they can move by themselves, which cannot apply to space cells. Rather, space can be compared to a soap foam, where every space bubble is always surrounded by other bubbles. Alternative theory of gravity, Part 2, where we'll talk about total energy of mass. This part is dedicated to probably the most mysterious property of the mass, its total energy. The famous equation E equals mc squared was obtained by Einstein when he worked on the special theory of relativity, calculating relativistic kinetic energy using Lorentz transformations. Einstein discovered an unexpected byproduct of these calculations to be an energy term, which does not vanish at zero speed. He called it rest energy. It is the energy which every massive body must possess even when at rest. To get the total energy of mass, the relativistic mass should be used in the equation. Let's consider the problem of the total energy of mass from the point of view of the new theory of gravity. In this new theory, absorption of space by mass is responsible not only for gravity, but also for the motion of mass in space. A massive object always absorbs space in the same quantity independent of its state of motion. It doesn't matter if it is moving or staying still. The total energy of mass can be defined as a sum of the gravitational and kinetic energies. Let's consider three different options for space absorption by a particle of matter. First, when mass absorbs space symmetrically relative to its center. In this case, the particle of matter cannot move in its surrounding space because any motion in one direction is always compensated by a motion in the opposite direction. Of course, a bigger mass absorbs more space and therefore has more lines of space absorption. These lines are equivalent to the lines of force for gravitational field. Depicted particle has no kinetic energy, but gravitational flow is maximal. In the case of symmetrical absorption, the total energy of the mass is equal to its gravitational energy. Another extreme case when a particle absorbs space only from one direction. In this case, no line of space absorption is compensated by absorption from the opposite direction, and therefore, the particle moves with the maximum speed, the speed of light. When mass is moving with the speed of light, it doesn't create any space flow towards itself. its total energy of mass is equal to its kinetic energy mc squared divided by 2. Why the total energy of mass is not equal to mc squared must be discussed later, probably in a later video when we'll be discussing nuclear bonds. And here we reach an important conclusion that mass absorbs space at the speed of light or even faster. This conclusion gives a physical meaning to the speed of light as the ultimate velocity of any material object. Let's talk a little more about mass as the property of matter to absorb space. I already mentioned that a larger mass absorbs more space cells in one cycle of space absorption than a smaller mass, and therefore has more space absorption lines. We can say that mass can be measured by the number of lines of space absorption, or by the average solid angle attributed to one line. The average solid angle specific to a certain mass can be calculated dividing the total angle of the unit sphere 4 pi, by the number of lines. Actually, a solid angle corresponds to the density of absorption lines, and in our case with symmetrical and uniform absorption, the distribution of the lines can be represented by a sphere. A uniform distribution of the lines of absorption means an equal acceleration of space flow towards the particle of matter from all directions, which is equivalent to a uniform gravitational field around the particle. Uniform gravitation in its turn indicates that the particle is stationary. Now let's consider an asymmetrical absorption of space by a particle of matter. This is the most common case, when particle of matter is moving with velocity lower than the speed of light. As we can see, the particle absorbs space asymmetrically, and therefore moves in the surrounding space in the direction where it absorbs more space. We can define a condition of motion of a particle using its solid angles. Frontal angles of the moving particle are smaller than the average solid angle, but the rear angles are bigger. The frontal solid angles of the particle of matter can be considered the same way as a de Broglie wavelength, which is inversely related to the momentum of a particle. Smaller angles correspond to a bigger mass and higher velocity. It is quite possible that when we measure the wavelength of a moving particle, using diffraction or interference patterns, we are actually measuring the solid angles of its space absorption lines. At the same time, every asymmetric distribution of the lines of space absorption can be presented as a superposition of the symmetric and asymmetric parts, which correspondingly represent the gravitational and kinetic components of the energy of mass. As we can see in this picture, the symmetric part of the moving mass which is responsible for its gravitational properties is not uniform, as contrasted to the uniform gravitational field of stationary masses. It can be represented by an ellipsoid whose axis of symmetry coincides with the direction of motion. Such a distribution of the density of the absorption lines indicates that the gravity of the moving mass is stronger in the direction perpendicular to its motion. It's important to notice that the shape of the gravitational field of the moving mass does not change when the direction of motion is opposite. I have to mention that every new theory has to predict something new, explain something that previous theories couldn't explain, or at least provide new, more obvious, and convincing explanation of a well-known phenomenon. Otherwise, why do we need new theories? Tidal forces are explained by contemporary physics using the difference in strength in gravitational field of another body. For example, the Moon attracts the closer side of the Earth slightly more strongly than the further side. I don't want to argue this explanation, but the new theory provides a different approach to this problem. It is based on the conclusion that a gravity field is stronger in a direction perpendicular to the motion. It means that the highest tides should happen when the Moon is on the same line as the Earth and Sun. Along this line things are getting heavier, not lighter as predicted by the regular theory but heavier. The bulges on the opposite sides of the ocean are created for the same reason as more iron fillings gather around the poles of a magnet, where the magnetic field is stronger. And this explanation of tides can be easily checked experimentally, which is important to verify this of new theory of gravity. Part 3. Newton's law of universal gravitation. A theory of gravity cannot be accepted if it doesn't derive Newton's law of universal gravitation. At least in the low energy limit. In the first part of this presentation we agreed that gravity is not a force and therefore Newton's formula for the force of gravity should be transformed into a formula for gravitational acceleration of the flow of space. And this formula for gravitational acceleration can be easily derived from the premises proposed, but with one condition. And the condition is, it is possible to obtain Newton's inverse square law, only if the volume of the space cells will be inversely related to the square root of the mass density, otherwise it won't be an inverse square law. This intermediate formula is very important in itself, because it shows that the size of a space cell decreases on its way to the mass and that its value is defined only by the local density of mass and nothing else. On the picture we can see a sphere around a mass. It's the gravitational sphere of influence where internal mass controls the size and, as we will see later, the speed of the space cells on their way to the massive object. The boundaries of this sphere are defined by the equality of the densities of the internal and external masses. The outer field, that I call background space, is under the influence of external mass which is much greater than the mass of the internal sphere and produces a much bigger sphere of influence. A good example is the solar system where the sun produces a huge gravitational sphere of influence covering all spheres of the planets, but the planets on their turn cover all their satellites. The gravitational sphere of influence is equivalent to the Hill sphere in astronomy. But let's return to Newton's law. The derivation of the equation for acceleration of space flowing toward a mass is based on an assumption that space absorbed by a particle of matter should be replaced by the flow of space from outside. We know that the mass can absorb a certain amount of space cells at once. The volume of absorbed space could be calculated by Formula 1. Or by Formula 2, where we use the notion of an elementary mass which absorbs only 2 space cells in a cycle and can be used as the unit of mass to measure all other masses. This elementary mass may be a purely theoretical particle or may be just the lightest known particle like a neutrino. By the way, the final products of annihilation of any pair of a particle and its antiparticle are photons and neutrinos. We also know that the volume of space cells is inversely related to the square root of the density of mass. Using these formulae we can obtain a formula for the volume of space absorbed by a particle in a time of one cycle. This volume of space is compensated from outside by the flow of space with the velocity v at a distance r. From the last equation we can get a formula for a velocity of space flow at a distance r. And after some transformation we can get a formula for acceleration. Or in the other form using gravitational constant. From the value of the gravitational constant we can make an assessment of the order of the linear size of space cell. We have to remember that L0 is the smallest possible size of a space cell on a surface of the particle. It is interesting that the formula for velocity of space flow exactly coincides with the formula for the escape velocity, which means that space is moving through the surface of the Earth with a velocity of 11.2 kilometers per second, which looks too high at first glance. This high speed of space flow cannot stay undetected. But let's look at the experimentally proven formula for gravitational time dilation. Here is the formula for gravitational time dilation if we write it in terms of time intervals. It can be compared with the time dilation due to relative velocity. We can see that if in the second equation instead of v, we'll use the formula for escape velocity, we get the exact equation for gravitational time dilation. So the high velocity of the space flow is confirmed by the equation for gravitational time dilation which was verified experimentally. Besides Newton's formula for gravitational acceleration, it is possible to get a very useful formula which connects the linear size of a space cell and its velocity under the influence of a mass m. From the formula for the volume of space cell and the formula for the velocity of the space flow, it is possible to get this equation. Or in another form, it shows that the product of the linear size of the space cell and its velocity is a constant for a given mass. Smaller space cells move faster than bigger ones, or decelerating cells are getting bigger and accelerating cells are getting smaller. Alternative theory of gravity. Part 4. Time. Here is the one of many descriptions of time. We have the illusion, at any given moment, that the past already happened and the future doesn't yet exist, and that things are changing. Everything in this description of time is true. But now let's talk about those basic properties of time which can be deduced from the new approach to interpretation of gravity. In a theory of gravity where mass is absorbing space, and motion in space is an intrinsic property of matter, time is shrinking to a point that we call now, and which means that ye have no time but this present. If there is no time except now, then now is absolute and the same for the entire universe. It means that time doesn't exist as a dimension and cannot be warped or bent as proposed by Einstein. At the same time, mass is absorbing space in cycles. It absorbs a certain amount of space cells at once, then another set of cells and so on. These cycles can be considered as a ticking clock inside a particle. The duration of one tick is a unit of time which can be calculated using the linear size of the space cells and the speed of space absorption. The linear size of space cells in this formula is a variable value and is a function of the velocity of the particle, its mass, and the background density of external mass. It means that every particle has its own rate of absorption of space cells and therefore has its own time. A shorter time unit means a faster time for the particle. The formula for time dilation in the new theory is slightly different from the formula that we know from Einstein's theory of special relativity. Besides the speed of light c, it also uses the speed of space absorption ca, which is always higher than the speed of light. I will not show the derivation of this formula, but I would like to note that in the new theory of gravity the real constant is the speed of space absorption, and the speed of light changes depending on the surrounding conditions. For example, the speed of light in glass is different from the speed of light in air, or in a vacuum. Generally speaking, the maximum speed of any particle or electromagnetic wave depends on the size of the surrounding space cells, but the speed of space absorption is always the same. We can get Einstein's formula well known for time dilation from equation 1, only if we assume that in certain conditions the speed of light is equal to ca. There is one more interesting conclusion which is possible to get from the formula for time dilation. If a particle moves with a velocity equal to the speed of light, then its time doesn't become infinity, as in the special theory of relativity. It has a real value which is possible to calculate using the following equation. Now we have come to the part where we'll talk about the implications of the new theory, about repulsion of masses and the critical density of mass. But first let's talk about real and fictitious forces. We agreed that gravity is a fictitious force, but what does it mean in terms of the new theory? A particle of matter moves in free fall with acceleration just because it is moving together with accelerating space, not because any external force makes it accelerate. Here we come to the conclusion that a real force must make mass accelerate in space. An acceleration in space happens when the solid angle in front of a particle gets smaller in time, or in the case of a repulsive force the solid angle behind the particle is getting bigger. When masses interact we are talking about a force of repulsion because in a certain condition masses start competing for space. Let's consider a situation when two material objects are moving towards each other and their spheres of gravitational influence intersect. At some point both objects will try to attract the same space cells, trying to absorb them. We know that decelerating space cells grow in size, which makes massive objects change their direction of motion. And this is an example of a real force, the force of repulsion. The real force between masses is repulsion. A force between matter and antimatter will be attractive. And now let's consider the concept of the critical density of mass, which comes from the new approach to the explanation of gravity. This concept can be explained by the example of a sphere of radius r, with mass m, and a uniform density of mass ρ. All the space inside the sphere is coming through its surface. The size of incoming space cells is defined by the density of mass. So, the surface of the sphere restricts the amount of space cells, which can move inside of the sphere, and therefore defines the maximal mass of the sphere mc. It is possible to derive an equation for the critical density of the mass, when the surface area of the sphere is big enough to take in the exact amount of space to feed the evenly distributed mass m. In logarithmic form it looks like this. This model of the critical density of mass shows the situation when particles of matter start competing for space within the limited volume of a sphere, and it is obvious that the particles located closer to the surface have the easiest access to incoming space cells, which means that the struggle for space between particles is going to be somewhere closer to the center. And the result of this struggle will be flows of particles directed towards the surface of the sphere. But the gravitational flow of space will move more mass toward the center, creating circular flows of masses within the sphere. The process like this can be observed in the depths of planetary objects. It keeps the center of the Earth hot and can do it eternally. Now we can consider the extreme case of critical density, when the density of the object is so high that its escape velocity is equal to the speed of light, which means that all the mass of the object has moved from inside to the surface. This is a model of black hole. We can describe this model as a sphere which surface is covered by elementary masses, and these masses absorb space only from outside. The formula for critical density in this case is different. This model suggests that the entire mass of a black hole is distributed by the surface of the sphere of event horizon, and there is nothing inside of this sphere except empty space with enormously big space cells. Concept of a critical density of mass eliminates an error of singularity for black holes. It explains not only a hot core of some rocky planets but also a low density of the massive objects including gas giants, stars, and even black holes. This concept can be applied not only to cosmic objects but to elementary particles also. The density of mass inside an atom's nucleus is extremely high, and competition for space can be expected inside the nucleus of the heavy atoms. Now we can analyze the objects in our solar system from the point of view of the concept of critical density. On this picture you can see all our planets and Sun on the same chart with the heaviest element, unoctium with atomic number 118. We can see that the formula for a trend line is different from the formulas derived from the proposed models, but we know that no one object on this chart fits exactly to any of the models I discussed. But if we'll try to put on this chart an object from our daily life, say a 100 kilograms body, then it will be necessary to squeeze this object to a sphere of 2 millimeters in diameter. But now let's consider the objects in our solar system more closely. We can see two groups of objects, the rocky planets with relatively high density of mass and a lower density but more massive group of gas giants and the Sun. All of the objects are stable and therefore located on the left side from the line of the critical density, but the distance from the critical line is different for each object. This distance defines their internal activity. In a low-density group of objects we can distinguish the Sun and Jupiter, which is often called a second Sun. And in the group of rocky planets, Venus and Earth are a distinct subgroup of very similar planets with known volcanic activity which reveals the hot and at least partially liquid cores of these planets. Venus has a slightly lower density than Earth and has no magnetic field, which may be a consequence of its extreme volcanic activity which spills internal masses to the surface of the planet, decreasing the density of the planet. Mars is distinct in the group of 4 terrestrial planets because of its low density, which predefines it to be a cold planet, but the number of huge dead volcanoes on its surface suggests that in the past Mars was much hotter. Using the concept of critical density we can assume that in the past Mars could have been hotter and denser, but volcanic activity cooled it by decreasing its density of mass and making Mars look as it looks now, a frozen, dead planet, with very thin atmosphere and no magnetic field. The new approach to explain the nature of gravity can be also helpful in understanding some other problems in contemporary physics. For example, the rotational curves of galaxies can be more easily explained when it's accepted that space can move under of mass, and that the density of mass defines its velocity. In the case of galaxies it won't be necessary to have more mass at the center, or apply a halo of dark matter to make a disk of galaxy rotate faster. These unusual rotational velocities of the spiral arms of the galaxies can be explained as a result of their relatively high mass density. Finally, I would like to remind you of a well-known saying of Einstein. Once he said about thermodynamics, a law is more impressive the greater the simplicity of its premises, the more different are the kinds of things it relates, and the more extended its range of applicability. In my opinion, it's an absolutely correct statement and its proposed criteria can be used for any theory, not only for thermodynamics. As you can see from this presentation, the range of applicability of my proposed theory of gravity is really wide, It can explain many things which were within the range of applicability of general relativity. This is the last slide of my presentation. Thank you for your attention and please write your comments to this video or ask questions. See you in new video. The end.